Hello, welcome to the Mark Janard Show, the cybersecurity show. In this video, I'm going to talk about these coding projects that are going to give you an unfair advantage. So without further ado, let's get right into it. We're going dark. So let's talk about the toughest languages. We have the Haskell, and the Haskell is a purely functional programming language renowned for its sophisticated type system and mathematical foundation. Now, here's what makes it hard to learn. Haskell's departure from imperative programming paradigms and advanced concepts like monads and immutability can be challenging for newcomers, right? The language demands a deep understanding of functional programming principles and a willingness to embrace a new way of thinking. So the pros of Haskell is it's a powerful type of system that helps catch errors at compile time. It also promotes a cleaner code and a less mutable state. It is grounded in mathematical concepts and formalism. The cons, however, it's less prevalent in commercial software development, and you're going to notice that trend. It's also non-intuitive concepts like monads and type classes can be challenging. Next, we have the next toughest one we have is Lisp, Lisp, and that it encompasses a family of programming languages known for their unique focus on code as data and data as code concepts. Now, why is it hard to learn? Lisp's syntax, which revolves around parentheses and manipulating code as data, presents a significant departure from conventional programming languages. Now, what this does is, this unconventional approach requires learners to adopt a fresh perspective on programming. So the pros of it is, a unique approach to code manipulation offers powerful capabilities, Lisp, right? It's also well suited for symbolic reasoning and artificial intelligence. It also has compact code due to a minimalistic syntax. The cons, however, is it's primarily used on academia, AI research, and specific domains. It also requires a shift in mindset from imperative languages. The next hard programming language is Whitespace, and Whitespace is an esoteric programming language that exclusively uses Whitespace characters for its syntax. Now, why is it hard to learn? Whitespace unconventional syntax, which lacks visible characters, requires developers to grasp code structure through Whitespace alone. This novel approach can be particularly challenging for individuals accustomed to traditional programming languages. Now, let's talk about the pros and cons. The pros are Whitespace characters, uses Whitespace characters for syntax, providing a unique coding experience. It challenges conventional coding practices, stimulating cognitive flexibility. It also focuses on the visual layout of code, encouraging creativity. Now let's look at the cons. Again, relying solely on Whitespace can lead to visually cluttering code, and there is a grasping code structure based on Whitespace alone that, can be confusing. Please take a moment to hit that subscribe button right now. Please take a moment to hit that subscribe button right now and that like button. Hit that subscribe button and that like button. The next one we have is Intercall, and Intercall, humorously referred to as Intercalate, is intentionally designed to be as unconventional and confusing as possible. Now, why is it hard to learn? Intercall's deliberately convoluted syntax and baffling constructs challenge traditional programming thinking. The language quirks and unorthodox features make it a formidable puzzle. The pros are it's designed as a parody of traditional programming languages. It fosters amusement. There's also the concept of it necessitates thinking outside the box due to unconventional syntax. Then there is the learning Intercall can be a memorable and conventional coding journey. Now the cons are it's primarily used for fun and intellectual challenges, not for practical applications, and it also requires unlearning conventional programming concepts. The next one we have on the list is Prolog, and Prolog is a logic programming language often employed in artificial intelligence and symbolic reasoning. Why is it hard to learn? Prolog's paradigm, based on logical rules and declarative programming, contrasts with the imperative style of most languages. Mastery of Prolog requires a firm grasp of symbolic reasoning and a willingness to dive into its unique approach. The pros are it's well suited for symbolic reasoning, artificial intelligence, and expert systems. It emphasizes what should be achieved rather than how to achieve it. It simplifies problem solving through pattern matching, and rule-based systems. The cons are, it has advanced concepts like backtracking and unification that can be intricate, and it's primarily employed in specific domains like AI and symbolic reasoning. The last one we have on this list before we talk about the toughest projects is Malbog. And Malbog is an esoteric programming language designed to be exceedingly difficult to program. Now, why is it hard to learn? Malbogs or Malbog, whatever you want to call it. Its convoluted design, lack of straightforward operations, and esoteric nature collectively contribute to its reputation as one of the most challenging programming language to understand and work with. So the pros are it's known for its difficulty and intentionally confusing design. Solving problems in Malbog offers a unique mental exercise, and it appeals to programmers interested in tackling extraordinary challenges. The cons are it's primarily used for humor, artistic expression, and intellectual curiosity. It's also limited real-world applicability due to its highly unclear nature. Now let's get into the toughest programming projects, okay? The toughest programming projects. Those are the toughest languages. Now let's get into the toughest programming projects. Number one, building a programming language from scratch, including a parser, compiler, linker, loader, and emulator. This involves understanding compilers and language design at a deep level. Number two, okay, that was number one. Number two is developing a game engine or operating system. These projects require a strong grasp of low-level systems, programming, memory management, and performance optimization. That was number two. Number three, implementing a database from the ground up. This will teach you about file systems, networks, query engines, and the internals of real-world databases. Next one, we have creating an interpreter or compiler by handwriting a parser. So while it may seem daunting, it's actually a great way to demystify parsing and compilers. The next one is building a reverse proxy from scratch, and this is an entirely useful project that involves insights into networking, proxying, and web architecture. So I'm hitting you guys with these, right? The next one we have is developing a search crawler or autocomplete system. Now, these projects require understanding computational efficiency, data structures like sets, and the challenges of scaling. The next one we have is writing a file compressor. This involves learning about compression algorithms, bit manipulation, and optimizing for space and speed. So those were some heavy hitters, guys. Those are the programming projects that's going to give you an unfair advantage. So how does building a compiler help in understanding programming languages better? So building a compiler can significantly improve your understanding in multiple ways. Number one, gaining insights into language design and implementation. Implementing a compiler forces you to deeply understand the language's syntax, semantics, and type system. And you will learn how to formally specify a language's grammar and how to implement type checking, type interface, and other language features. The next is understanding parsing and syntax analysis. So writing a parser for your language's grammar teaches you about parsing techniques like LL, LR, and LALR parsing. You'll learn how to build abstract syntax trees, also known as ASTs, and how to perform semantic analysis on those trees. The next is learning about code generation and optimization. So implementing a compiler's code generation phases gives you insights into how high-level language constructs map to low-level machine instructions, and you'll learn about register allocation, calling conventions, and other compiler optimizations. And again, you will also appreciate the challenge of language implementation. So that's what I have for you today. Please take a moment to hit that subscribe button and the like button. Take a moment to hit that subscribe button and the like button right now. I appreciate your viewership. Stay safe. See you in the next video.